Good morning friends. Today we are going to start our discussion about the wave optics. Up to this we discussed about the ray optics and also the phenomena of light like as the reflection and refraction of light we discussed by considering the light as a ray. Light as a ray. It means by considering the particle nature of a light we explain the two phenomena, reflection and refraction, and also we deal the Snell's law. Now in this chapter we consider the light is behave as a wave, not a particle. Not a particle, it behaves as a wave. Or by considering the light as a wave, we are going to discuss the remaining phenomena of light, like as the interference, diffraction, polarization. We are going to learn in this chapter by considering the light as a wave. Okay. Now first, here what is the visible light? How we define the visible light? Actually the light is an electromagnetic spectrum. Light is the electromagnetic spectrum. In electromagnetic spectrum, the portion of wavelength 4000 angstrom to the 8000 angstrom is visible light. Again, in electromagnetic spectrum, the portion of wavelength 4000 angstrom to the 8000 angstrom is visible light. Actually, in electromagnetic spectrum, here the different portion, like as the X-ray, gamma rays, radio waves, right? So this type of the different portion of the electromagnetic waves according to its wavelength and frequency. Therefore, the portion of electromagnetic waves in this portion having the wavelength 4000 angstrom to the 8000 angstrom is considered as a visible light. Actually, the light itself invisible. This visible light is invisible. Okay. Now, what are the views of the light? What are the different views on the light? Here, generally we know that light has two different views. One is the particle nature and second is the wave nature. Now, first is the Newton's particle theory of light. So, Newton considered the light as a particle and suggested the some phenomena of light, and that is also the corpuscular model of light. That is also the corpuscular model of light. That means the Newton's particle theory of light. Okay. The particle theory of light said by Descartes in 1637. That means the light is behave as a particle is first introduced by Descartes in 1637 and derived Snell's law and explained the laws of reflection and refraction at the surface separating the two medium. Again, in 1637, the Descartes shaped the particle theory of light and explained the laws of reflection. And also the reflection at the surface separating the two medium. Already we discussed in earlier chapter what is the phenomena of reflection at the surface. In phenomena of reflection, we know that when the ray of light is traveling from one transparent medium to the another transparent medium, so the direction of incident light is changed at the surface separating the two medium. Either the reflected wave, the reflected light is bent towards the normal or bends away from the normal. Now, the particle theory of light predicted that if the ray of light bends towards the normal, in phenomena of reflection, if the reflected ray bends towards the normal, then the speed of light is greater in the second medium. So, what the particle nature of the light suggested? The particle theory of light suggested that if the light entering second medium is bent towards the normal, the speed of the light in second medium is more than the first medium. And from this, according to this theory, the speed of light is less in rare medium and more in denser medium. Because already we discussed about that. When the ray of light is traveling from rare to the denser medium, at that time the refracted ray bends towards the normal. So according to the theory of this, it means according to the theory of particle, we can say that the speed of light in rare medium, in first medium, is less and more in denser medium or the other medium. Okay. In this theory of light is considered to be composed of this small particle. According to this theory, that is suggested by Descartes. So according to this suggestion, the light is made up of the numbers of the small particles, therefore that is known as the particle theory of light. Now the second view is suggested by the Huygens. So that is known as the Huygens wave theory. So Huygens put the wave theory of light. So Huygens considered the light is behave as a wave, while the Newton is considered that the light is behave as a particle. So according to Huygens, this theory explains that the phenomena of reflection and refraction. By considering the wave nature of the light, we can also explain the phenomena of reflection and refraction. It predicted that if the wave bends towards the normal, now according to the wave theory, what's happened? Again, in phenomena of refraction, if the reflected ray bends towards the normal, so the speed of light would be less in the second medium. So, according to the wave theory, the wave theory suggested that if the light is bent towards the normal, the speed of this light in second medium is less. While in particle theory of light, the speed of a light in second medium is greater than the first medium. Okay, so this is contradiction to the prediction made by the particle theory of light. So this statement is contradictory statement compared to the particle nature of light. In particle nature of light, if the wave or the ray bends towards the normal, so the speed of a light in second medium is more. While according to the wave theory, if the wave bends towards the normal, so the speed of the light in this medium is less. So there is a contradictory with the particle nature of the light. So in 1815, the Foucault predicted that the speed of light in water is less than the speed in air. So if Foucault, from the numbers of the experiment, also predicted that the speed of light in water, that means the denser medium, is less compared to the speed of light in air, that means the rare medium. So wave theory suggested that the speed of light in denser medium is less compared to the rare medium, while the particle theory of light suggested that the speed of light in denser medium is more than the rare medium. Okay, now after the discussion of the visible light, now what was the difficulty in establishing the wave theory of light and who explained it? Now, for that purpose, in the earlier portion we discussed about that the different view of light are the particle nature of light and also the wave theory or the wave nature of light. Both are suggested by the different scientists. The particle nature is generally suggested by the Newton and the wave nature of the light is suggested by the Huygens. Okay, now what are the difficulties to establish the wave theory of light? Now we know that to travel, the major difficulty in establishing the wave theory of light was that a wave required a medium for propagation. The wave required the medium for propagation. Already we know that the sound wave travels to the air medium. Without the air, we can't listen to the sound. That means for the propagation of the sound, here the medium is required, air medium is required. What are the ways to produce in a string? Already we learned in Milan standard. So medium, that means the string is required. Without the string, the waves cannot propagate in the medium. Therefore, the main difficulty is that the Bell theory of light was that the wave required a medium for their propagation. And so question arises in our mind that the light waves coming from the sun, between the sun and earth, some distance or some region, no medium is present. In spite of that, the light wave travel from sun to the earth, that means to the free space or the vacuum. So question is that how would the light wave traveling to a free space or the vacuum? We know that the wave requires a medium for the propagation of the traveling. But the light wave traveling to a free space or the vacuum. Why? What is the reason? Why this answer we discuss? For that purpose, the Maxwell had developed a set of equations describing the laws of the electricity and magnetism. So, the difference of the electricity and magnetism already we learned in chapter 1, 2, and also chapter 4, 5. Faraday's law, Ampere's circular law, and also the Coulomb's law. Right? And also the closed loop formed by the magnetic field lines. So using this concept, the Maxwell derived the four equations, and these equations are known as the Maxwell's equation. Right? So describing the laws of electricity and magnetism. Using this equation, he derived the wave equation for which he predicted the existence of electromagnetic waves. So after deriving this equation by using the laws of electricity and magnetism, so Maxwell derived the four equations, or the set of four equations for electromagnetic, or the electromagnetism. And he also developed or predicted that the existence of electromagnetic waves. And after that, what are the electromagnetic waves are obtained? He found the speed of these electromagnetic waves in a vacuum. This speed is very close to the practical vacuum. So from this equation, the Maxwell calculated the speed of electromagnetic waves in free space or the vacuum. He found that the theoretical value was very close to the practical value of the speed of light in vacuum or the free space. So here the answer to this question, here the wave required the medium for the propagation, but the light wave not require the medium or the light wave also traveling in a vacuum or the free space. For that purpose, the Maxwell developed a set of equations by using the laws of electricity and magnetism, and developed the equation. And from this equation, he predicted that the existence of electromagnetic waves. Now, from this equation, the Maxwell calculated the speed of electromagnetic waves in light, in free space or vacuum. He also found that this calculated value is very close to the speed of light in vacuum. Thus, he proved that the electromagnetic waves are the light waves. Electromagnetic waves are light waves, and he also predicted that the light is behaved as a wave. Light is behaved as a wave. According to Maxwell, the light waves are associated with the changing electric and magnetic field. He also proved that this electromagnetic waves is the combination of the electric field and magnetic field. So as the wave is passing, so the value of electric and magnetic field continuously changing with time. Therefore, the continuous changing electric and magnetic fields produce the electromagnetic waves. Thus, the changing electric and magnetic fields result in the propagation of electromagnetic waves in vacuum. Electromagnetic waves in vacuum. So there is the answer why the light also propagated the traveling to the vacuum. We know that the wave requires the medium, but the light is also traveling to the vacuum. Because the Maxwell proved that the light waves are the electromagnetic waves, and he also calculated the speed of light waves or the electromagnetic waves that is very close to the speed of light in vacuum. So he proved that the electromagnetic waves are the light waves. But the light waves is the one type of electromagnetic wave. And according to Maxwell, the light waves are associated with the changing electric and magnetic field. Thus, the changing electric and magnetic field result in the propagation of electromagnetic waves in vacuum. Thus, the wave requires the medium, but here the light or the electromagnetic waves do not require any medium for their propagation. After that, what is the wave and wavefront? Now, wave is that the disturbance propagated in medium is known as the wave. Now, we have the experience as we throw a small stone in the water. Initially, the water is stationary. As we drop a small stone, what's happened? The circular rings are produced, and these rings are going to enlarge. That means they expand. So that shows the waves are due to the drop of a stone in a water. So here the disturbance is produced, and this disturbance is propagated in all directions. Therefore, the circular rings are generated. Each and every circular rings is our wavefront, and this behavior that is known as the wave. That means the disturbance is propagated in all directions. That is our wave. Now here the figure is shown. Yes, we drop a stone, what's happened? The circular rings are shown. And these rings are spread out from the point at which the stone is dropped. So here, each circle acts as a wavefront, and this phenomena is the wave. Actually, what's happened? The effect of the oscillation of the particle in a medium that is transferred to the another medium of the another particle of the medium. So what's happened? The neighboring particle also start the oscillation. Therefore, the effect of the simple harmonic motion is transferred from one particle to the another particle in the medium, and this effect is known as the wave. Now, we are going to discuss about the wave and wavefront. When a small stone drops in the water, the waves spread out from the point of impact. Every point of the surface starts oscillating with the time. At any instant, the surface would show the circular rings, on which the disturbance is maximum. So here the circular rings are shown, on which the disturbance is maximum. Therefore, all the points in such circle are oscillating in the same phase. What are the points? Are line points. Each circle are oscillating in the same phase. Therefore, at the same time, all are at the maximum displacement. Therefore, cover the one circle. Okay. The same phase because they are at the same distance. So here, whatever the stone is drop in the water. So as a result, the disturbance is produced. This disturbance travels in all directions with the same speed. Therefore, what are the particles at the equal distance from the point are oscillating with the same phase. That means when the particles are at the maximum distance at the same time and at any distance at the same time. And that becomes the wavefront. Okay. Now, the circle passing to the point which oscillate in same phase is known as the wavefront. Actually, there is the imaginary surface which passing to the point. This point oscillating in the same phase is known as the wavefront. Thus, the wavefront is the surface with the constant phase. So, in other words, the wavefront is the surface with constant phase. Again, all the points on such circle are oscillating in same phase because they are at the same distance from the shore. Therefore, the circle passing through the points which oscillate in the same phase is known as wavefront. So here there is also the one circle. All the points are oscillating in the same phase. Second circle also here all the points on this circle oscillate in the same phase. But here the phase of the first circle and second circle are not same, are different. But what are the points on in one circle are oscillating in the same phase? That is known as the wavefront. And thus the wavefront is the surface of the constant phase. So on this circle the phase is constant at all the points. The speed with which the wavefront moves outward from the source is known as the speed of a wave. Now, just we discussed about that due to the drop of a stone in the water, so circular rings are spread out. What is the speed of the ring are going to spread out? That is the speed of a wave. Again, so these circular rings are spread out from the center. So the speed of this circular ring spreading out from the source is known as the speed of the wave. Actually, there is in three-dimensional direction. Actually, what's happened? If we consider this side, so disturbance is like this. So there is the point of the circle, and with the displacement is maximum. And this dot line here, the displacement is minimum. Again the maximum, again the minimum. So here the circles are dash and also continuous line. So they are continuously spread from the source. So whatever the speed of this source are spreading, that is known as the speed of the wave. Now, the energy of the wave travel in the direction normal to the wavefront. Now, actually why the rings are spread out? Actually the effect of the oscillation of the particle is transferred to its neighboring particle. Why the neighboring particle start the oscillation? If and only it gets the some energy from the neighboring oscillating particle. If this particle gains the energy from this oscillating particle, after that this particle start the oscillation. Therefore, not only the wave is propagating, due to the traveling of the wave, the energy is also traveled from one point to the another point in the medium. Therefore, the energy of wave travels in direction perpendicular to the wavefront. That is the wavefront. So, energy is propagated in this direction or travel perpendicular to the wavefront. Now, the light global to the wavefront and indicating the propagation of the wave, that is known as the ray. That is known as ray. The line global to the wavefront and indicating the propagation or the motion of the wave, that is known as the ray. And thus the wavefront and ray both are perpendicular to each other. Therefore, here the ray is this. So these circular rings are the wavefront. Therefore, the wavefront and ray are perpendicular to each other. Hear this? So there is the concept of the wave and wavefront. Keep in mind that during the propagation of the wave, not only the wave are propagated, but here the energy is also propagated in the direction perpendicular to the wavefront. Clear this?